All right, moving into Pythagorean Theorem. Remember, this is only used on right triangles. So it's important to know the pieces of Pythagorean Theorem. In a right triangle, you have two legs and a hypotenuse. The hypotenuse is really what matters. The hypotenuse has to be your c. So in Pythagorean Theorem, a squared plus b squared equals c squared. C is always going to be your hypotenuse. If you're looking for it, find your right angle and travel across. That's going to be your hypotenuse. That's going to be your C. Now the other two sides are called legs. And it doesn't matter which one you call A and which one you call B. So A and B don't matter as much. So let's try it. So again, I always look at that right angle. All right, look at that right angle, travel across, that's your C, that's your hypotenuse. The other two are A and B. So we're going to plug in a squared plus b squared equals c squared. A and b are x and 12. Again, doesn't matter which one you call which. So we'll say a is x squared, b is 12 squared, and we know c is 15 squared. And then you have to do a little algebra from there. So let's do our exponents. We're going to leave x squared alone. 12 squared, so 12 times 12 is 144. 15 squared, so that's 15 times 15 is 225. And remember, your goal here is to get x alone. So we're going to subtract 144 from both sides. And we get x squared equals 81. And then your last step is to take the square root. So the square root of x squared is x, and the square root of 81. So we get x equals 9. Now, with Pythagorean Theorem, you can always double check to make sure that your answer makes sense. Your hypotenuse should be your longest side. So before you did this problem, you knew your hypotenuse should be your longest side. You knew your answer had to be less than 15. If you mess up Pythagorean Theorem, usually you wind up with a silly answer, like you would have told me that this was 20. Again, you know it has to be smaller than 15, so hopefully that would throw up some red flags. All right, let's try another one. Again, my first step is I always identify my hypotenuse, travel across, that's my C. A and B are whichever one you want to call which. So let's set it up. A squared plus b squared equals c squared. So we have 6 squared plus 4 squared, or you could have said 4 squared plus 6 squared, equals x squared. Do a little algebra here. 6 times 6 is 36. 4 times 4 is 16. And then we're going to combine our like terms. So we have 36 plus 16 gets me 52. And remember, your last step is to take the square root of both sides. Now's a good time to talk about answers. They could have two separate sets of directions. One could say simplest radical form. Which is another direction for exact. They don't want you to round anything. So, or they could tell you round to the nearest, let's say 10th. So those are two different directions you might encounter. So how do you go about doing them? Well, if it says simplest radical form, we're going to leave that square root of 52. And we're going to look for numbers that we know the square root of, that go into 52. So we can actually rewrite 52 as 4 times 13. And the reason I like 4 is because I know the square root of 4. So when I'm simplifying, the square root of 4 is 2. We can take it out. I don't know the square root of 13, so I'm going to leave it alone. And that would be simplest radical form. Round to the nearest tenth means you're going to type in the square root of 52 into your calculator. So we're going to type in 52 and take the square root, and to the nearest tenth we have 7.2. And again, both of these are correct answers, just depending on what the question asks. Now, again, I would always go back and double check, make sure your answer makes sense. Is my hypotenuse the longest side? Well, 7.2 is definitely the longest side here. So you knew your answer had to be bigger than 6 to start. So many bells. Next one's a doozy. So we're still going to find our C, right? Travel across. Other two are A and B. So we have A squared plus, now B is x minus 1 squared equals C squared. So 5 times 5 is 25. Now, x minus 1 squared, I'm going to go ahead and bring this over here. This is FOIL. You might have learned the area, the box method too. Make sure you multiply everything. So it's x times x, x squared. X times negative 1, negative 1x. And then you take that negative 1 and do the same thing. Negative 1 times x. And negative 1 times negative 1 is positive 1. Combine like terms, so you have x squared, negative 1x makes negative 2x plus 1. So that's just a little review from Algebra 1, foiling. So we're going to go bring that back here. So we had x squared minus 2x plus 1, so that's that foiled out. And this one obviously looks a lot different here. I'm going to combine like terms, 26 plus x squared minus 2x equals x squared. Let's subtract x squared from both sides, and some nice stuff happens here. So we have 26 minus 2x equals 0 now. We'll add 2x to both sides and divide both sides by 2. So find the value of x. X is 13. And then again, you can go back and plug it in and make sure it makes sense. 13 minus 1, the side is 12. X is 13. So is my hypotenuse my longest side? Yes, 13 is the longest side. So that is a little review from Algebra 1 there. You can also use Pythagorean Theorem to classify triangles, because a squared plus b squared is not always going to equal c squared. Sometimes c squared is bigger, right? Greater, and it's obtuse. Sometimes c squared is less than is acute. So Pythagorean Theorem actually tells you more than just right triangles. It tells you what type of triangle it is depending on what happens. So let's try. So the directions say tell if the measures can be the side lengths of a triangle. So we've got to remember if you add any two side lengths, it should always be bigger than the third. So here, 6 plus 8 has to be greater than 14. Is it? Well, 6 plus 8 is 14. Is 14 bigger than 14? Not a triangle. So definitely test if it can even be a triangle. And then if it can, then we'll use Pythagorean Theorem. So here, 4 plus 4, pick your two smaller sides. 4 plus 4 has to be bigger than 5. Well, is 8 bigger than 5? Yes, it can be a triangle. So now that we know it can be a triangle, we're going to try to classify it as acute, obtuse, or right. So let's set up our Pythagorean Theorem. I'm going to put C first. So C is always your biggest. So we're going to say C squared. Now, I don't want to put equals because I don't know. It could be greater than, less than, or equal to. a squared plus b squared. So again, c will always be the biggest number. 5 times 5 is 25. Again, don't know what's going to happen. And we got 16 plus 16. So here we have 25, and then 16 plus 16 is 32. So 25 is definitely less than. And when I think less than, I think acute. C squared is less than. Now, a lot of people freak out when they see square roots, but understand when you're plugging into Pythagorean Theorem, those squares and square roots will cancel out. It'll actually be very nice for you. So how do I know which one's the biggest here? How do I know which one's my C? You could always type in square root of 42. You know it's going to be a little bit less than 7, right? Because the square root of 49 is 7. So it's going to be 6 point something. So that's definitely going to be my C, my biggest side. So we got 42 squared. Again, don't know what's going to happen. Greater than, less than, or equal to. And then 5 squared plus 4 squared. So the square root of 42 squared, the square and the square root will cancel out and you'll be left with 42, which is very nice. 5 times 5 is 25, and 4 times 4 is 16. So you have 42, we don't know what's going to happen, and then 25 and 16 makes 41. So 42 is greater than obtuse. And I totally forgot to check if this could be a triangle. Remember this was 6 point something? Let's see what it is exactly. The square root of 42 is 6.5-ish. So this is 6.5-ish. Just so you have like a little thing to go on here. And then pick your two smallest sides. So 5 plus 4, 9 is bigger than 6.5. So 5 plus 4 has to be bigger than 6.5. And 9 is definitely bigger than 6.5. So I totally forgot to check, is it a triangle first? Because it's silly to tell me acute if it's not even a triangle to begin with. Alright, so that's classifying acute, obtuse, and right. And the last part just talks about something called a Pythagorean triple. A Pythagorean triple is where all sides are nice whole numbers. Nice whole numbers. I had a little typo there. Side lengths form. So the most famous Pythagorean triple is a 3, 4, 5. So it's a right triangle, 3, 4, 5. And all the numbers are whole numbers. That's just a famous one that everybody kind of remembers and knows. All right. So let's see if these are Pythagorean triples. They're both starting off good. They all have nice whole numbers right now. But we got to find that missing side length. So remember, here's my right angle. It's tiny, but it's there. So this is my C. A and B are the other two. So A squared plus B squared equals C squared. So we got 64 plus 225 equals x squared. And then we're going to combine like terms. So we've got 64 and 225 makes 289. And your last step is to take the square root, and the square root of 289 is 17. So again, make sure your answer makes sense. My hypotenuse is my longest side. And yes, it's a Pythagorean triple. Because all of them are nice whole numbers. Let's do the next one. C is 12, so 8 squared plus y squared equals 12 squared. We got 64. I'm trying to speed it up so I beat the clock. 144. We're going to subtract 64 from both sides. So you got 144 minus 64, and you get 80. And then the square root of 80 is about 8.9. And that right there makes it not a triple. I mean, it's a right triangle, just not a Pythagorean triple. Bye.